Thanks, everyone. I'll start with my introductory slide and then go from there. So I'm, as Mr. Murthy mentioned, I'm Tirthankar Barari, in short TR. I'm a cloud solution architect at Microsoft. My background being mostly on the data and AI side in Azure in the cloud. I work for the financial services and insurance vertical at this moment within Microsoft in the US markets. So my topic today is responsible AI practices and principles. So what is responsible AI? Well, it is the entire ecosystem for advancement of AI, driven by ethical principles that put people first. This includes the government to build regulations to prevent any harm to society. This also includes the innovators to ensure responsible development that has a positive impact to all. There is no harm and no bias in embracing responsible AI in this system. Now, with the proliferation of different AI systems and services and softwares and tools, there are a lot of societal concerns that we hear about recently, like facial recognition, the privacy of individuals, where randomly many places we see facial recognition is being used. Deep fakes is another example where people are being misled by information that comes through the use of deep fake technology. Then consent and contact tracing is another example. Although contact tracing can be used for things like we are using it now for the epidemic that we are all facing. But on the hindsight, there is also privacy issues and concerns about how far can we go with the contact information, making sure that it is used for the rightful purpose. Similarly, another concern is disappropriate or disproportionate impact of AI, where only a certain group of people get the benefit of AI systems, not everybody. That is also another concern. So basically, we need to make sure that all the AI technologies, the positive impact spans across everybody in our society. Now that we have an idea about what responsible AI is, you may ask, why responsible AI? If I own a small business, or say if I am in the leadership position in a mid-size or a large enterprise, why should I care about responsible AI? Well, this recent Capgemini report showed that 9 out of 10 executives have reported facing ethical issues in the implementation of AI. And if you see, the numbers are quite alarming. It's about everywhere across the globe, different countries, their executives have faced ethical issues to the extent of more than 80% in each country. So it's quite alarming, and we have to take it very seriously. These executives cited reasons, including the pressure to urgently implement AI was one of the reasons that they had faced ethical issues. Another one was that they there was a failure to consider ethics when constructing AI systems. They built the AI systems without doing due diligence, without looking at the failures that might happen because of not considering ethics. And also a lack of resources dedicated to ethical AI systems. That's also another very important factor where, if your people are not trained enough, and if you don't have right resources, it becomes very difficult to embrace AI systems in a responsible fashion. One thing that we come across quite often is fairness in AI. What is it? There are many ways that an AI system can behave unfairly. For example, a voice recognition system might fail to work as well for women as it does for men. For example, another one is you have built maybe a screening application based on AI to screen for loans, for jobs. Now that model, if it is not carefully built using responsible AI, using fairness, might be, picking up good candidates from a particular segment. Like, for example, maybe white men are given preference than other groups. So the AI system that you have built is fair to one category of people, but not every category of people. So there is bias in it. So fairness in AI is to make sure that you avoid negative outcomes of AI systems for different groups of people. Now, how do I embrace responsible AI in my organization? Well, the questions are like, how do I build AI systems that impact individuals and society in a positive way? That is the question that we have to answer when we are embracing responsible AI. How do you ensure AI system is treating everyone fairly? And also, how do we prepare our workforce, individuals, and society at large for this new age? Well, in order for your organization to develop and deploy AI in a responsible manner, you should first ask some of these questions as to how can you use a human-led approach to drive value to your business? How will your organization's foundational values affect your approach to AI? For example, if you are a nonprofit organization that is doing good for society, then your foundational value is that, right? And then your approach towards AI would be different from, say, an organization where one of the core foundational values is, say, providing best of class service to its customers, right? So if your foundational value is to provide best in class service to your customers, then your approach to AI would be a little different from, say, for example, that nonprofit organization. So you need to make sure that your approach to AI matches your foundational values. Then another thing to also consider is how will you monitor AI systems to ensure that they are evolving responsibly? Now, here are 6 principles that are guiding Microsoft's responsible AI development and use. I took this as an example as it touches upon all the key components of principles of responsible AI. The first one is fairness. AI systems should treat everyone fairly and avoid affecting similarly situated groups of people in different ways. Next is reliability and safety. Testing makes sure that your AI system is reliable and safe. Rigorous testing to ensure AI systems can respond safely in unanticipated situations and edge cases to avoid dangerous consequences. As an example, you may have built a self-driving car that uses image to identify whether the person is in front of the car so that it can brake. But if your system is not well tested, it may not detect a certain class of people as human in front of the car, and it might not brake. That will be a dangerous consequence, right? You don't want to be in that situation. So you have to make sure that your AI system is built reliably and works safely. Also, over time, as we all know, that models become unreliable and inaccurate because data drifts. So you have to make sure that your model is accurate and up to date. And above all, human judgment is key to identifying potential blind spots and biases in the model. The next one is privacy and security. We all know that data is fundamental and essential to building successful AI models. We need the data to train our models so that it works efficiently when it is predicting something, right? So while data is crucial, we also have to make sure that the data privacy and compliance and regulations are met in our system. So access to data is essential for AI systems to be accurate. So data privacy and security compliance is vital to ensure that the collected data that is used by AI is handled responsibly. Next one is inclusiveness. Everyone should benefit from AI technology. You should recognize exclusion and learn from diversity in your system and in your organization. Build AI systems that solve for one and extend to many. Next one is transparency. People must understand how you are making decisions. For example, a bank is using an AI system to decide creditworthiness of the customer. So people should understand, should know how the bank is using it for deciding creditworthiness. Be honest about when, why, and how your business is choosing to deploy an AI system. Then finally, accountability. Have internal review boards to provide insight and guidance on AI systems development, testing, and deployment. Ensure no harm is done in such systems. Ensure AI systems are not the final authority on decisions impacting human lives. Humans should maintain meaningful control over AI systems. You have to have complete log of your audits, your activities, so that you can manage the accountability. These are the 6 guiding principles. What is responsible machine learning? Responsible machine learning has these 3 foundational pillars. Understand your machine learning model, then protect the data that is used in your machine learning system, and then control the system where you have got audit trails and you know full details about the entire life cycle of your machine learning system. So the first pillar, which is understand your model. Say, for example, a loan application decision, right? When you create a model for your loan application acceptance, you have to have not only the trained model, but also should be able to interpret how the decisions are being made by this model. So InterpretML is an open source package by Microsoft that is used to interpret and explain your ML models. It is available in GitHub. You can download and use in your application. Also, fairness. FairLearn is another open source package that can assess and mitigate the potential unfairness of AI systems. It is also available for download from GitHub. This actually helps you to determine the unfairness of your model, and then also provides you algorithms to mitigate. Now, under interpretability, these are some of the libraries, some of the packages that are available. InterpretML, Interpret, as I said, is an open source package that incorporates interpretability techniques under one roof. With this package, you can train interpretable glass box models and explain black box systems. So in the glass box models, you can interpret clearly as to which feature had the most impact on a particular decision. For black box models like neural nets, where you won't be able to interpret clearly, you will be able to explain using some of the explainers how a particular decision was derived. Some of the explainers that are available for the black box models are SHAP, Lime, Global Surrogate. These are all available in the GitHub to learn more. Some of you, I'm sure, have already used it. On the glass box models, explainable boosting machines, EBM, which came out of Microsoft research, is a glass box model which is accurate as some of the black box models, but unlike them, it produces lossless explanation, meaning that EBM, that means explainable boosting machine, is accurate and at the same time explainable or interpretable. Generally, some of the algorithms are either very accurate but not intelligible, or intelligible but not accurate. But EBM is one example where it is both accurate and intelligible. So interpret in general is where it sort of helps you understand why a particular, say, a loan application was rejected. Was it the age, or was it the income of the person that contributed to that decision? Another way of providing additional information or interpretation to the model is done by DICE. DICE is diverse counterfactual explanations for ML classifiers. That's what it stands for. But what it does is, instead of ranking features by their predictive importance, like age or whether it's the earning of the person, DICE interrogates a model to find required changes that would flip the model's decision. For example, it might give you the information as to, you would have received the loan if your income was $10,000 higher. So instead of saying that your loan was denied because your earning wasn't up to the mark, it says that, well, your loan was denied, but it was if you had $10,000 more in your income, or if your age was 5 years more, then you would not have been denied, or you would have been approved for the loan. So that's DICE, once again, an open source package that you can use to get these kinds of information. Now, interpret text is another open source interpretability techniques for NLP models, natural language processing models, and a visualization dashboard that comes with it to view the results. So here you see, say you have got a document, a text document, and you are classifying the text document, saying that this document is a fiction or this document is a non-fiction. So interpret text would tell you that these are the 5 most important keywords that led to classifying the document as fiction versus non-fiction. So it provides that kind of interpretability. You can also, if you see the slider on the top, you can also say, give me the 4, 5, 6, 10 most important words that led to the decision to classify this document as fiction. In this case, say, for example, train, dragon, travel, these are the important words that led to the decision in classifying the document as this text or these sentences as fiction. As I mentioned earlier, fairness mitigation using FairLearn, which is an open source software, allows you to determine the fairness criteria, which is demographic parity or equal as odds. Based on that, it will tell you whether your model is fair or unfair. If it is unfair, it also provides you mitigation algorithms through which you can reduce the unfairness of your model. Here you see in this particular model comparison, as your accuracy increases. As your accuracy increases, unfairness also increases. The discrepancy also increases. But using fair learn, you can manage to come to a sweet spot where your accuracy and unfairness match the requirement criteria of your use case. Now, the second pillar of responsible machine learning is protect. As data is vital, as I have mentioned, it is important to make sure that you have the data protected. So differential privacy is one of the techniques that is used to hide the contribution of the individual by adding noise. White noise is an open source software package that is used to add noise into the data. Some of the key points here is epsilon. Epsilon is how noisy or private a report is. It's a measure of that. Delta is a measure of the probability of a report not being fully private. So this gives an idea as to how much of data has been hidden and privacy has been maintained. Another metric is another point for differential privacy is privacy budget. This is where, say, for example, you are querying the data as to how many people are, give me the salary, for example, give me the salary of people who work in the financial services in the Boston area, right? Maybe your data set has got only 4 people with their salary. So if that data is returned to the person who is querying, he will easily be able to identify maybe the people and their salaries. So the privacy will be compromised, right? So white noise is added to it so that the person cannot easily identify the individuals. But if I keep on querying quite often, if I query 10,000 times maybe, then I might be able to filter out the white noise and get to the actual data. So what they do is they rate limit multiple user queries to ensure privacy so that you cannot query 10,000 times and then finally get to the actual data. Another package that is used using the concept called homomorphic encryption to protect the data is here. So I'll quickly go through a simple use case. Basically, what it does is your AI system works on encrypted data. And when it is working on encrypted data, it doesn't know the actual user data, so user's privacy is maintained. So give you an example. Say here, you have got the 2 numbers, right? 3 and 5. Say, I'm just cooking up an example. Say this AI system predicts your salary based on your experience on different languages. Say if you have got 3 years of experience in Java and 5 years of experience in Python. Now, can the system predict what your salary will be? You could build some sort of ML models that will do that. But that's not the point. The point here is the systems. So I'm sending 3 and 5, encrypting them with an encryption algorithm. So the AI system only gets the encrypted data, 6 and 10, corresponding to 3 years of experience in Java and 5 years of experience in Python. Now the AI system, very simple in this case, it says that, oh, just add up the total experience and that will be your salary, just hypothetical. So the AI system then adds 6 plus 10 and gets 16, and that is its predicted value of the encrypted, it's encrypted value of the prediction. So it says 16 and then passes 16, that gets decrypted, and then the end user gets 8. So the end user now knows that if I have got 3 years of experience in Java and 5 years of experience in Python, then the predicted salary is say $8,000 or $80,000, whatever it is. But the point here is the end user has never shared the plain text data with the AI system, but still got the prediction back. So that was the example of how homomorphic encryption is being used to protect the privacy of user. Now I'll go into the third pillar, which is control. Of course, in control, you have to have audit trail. Basically, all the information about where your data is, how the data is being used to train the model, the entire life cycle of the machine learning model, and logs. All these things you have to keep to have it audit trail. And then datasheets is another open source system that allows you a way to document machine learning assets created and used in the ML lifecycle. For datasets, it provides how and why a dataset was created, how the dataset should or should not be used, and potential ethical and legal considerations for the dataset. Now, for models, the dataset and the datasheets system can provide information about the intended use of the model, and also how a model was built, trained, and so on and so forth. So with that, I had the overall summary of what I had to share. I can do a quick demo really quickly. I think if I share this here. So here is my Jupyter notebook in which I'm using interpretML. So first, basically, I'm installing interpretML package so that I can interpret my machine learning model. So after that, I'm getting the data. The data is US Census data for adults from the 90s. And I have trained my model using I'm splitting my data into training data and test data, and then I'm just showing the data here. It's basically age, work, education, marital status, occupation, blah, 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 of different people in the data set. Just the histogram of the data shows that when I'm young, for people who are younger, their predicted salary or their salaries are below 50K. That's what I'm basically building. I'm building a classifier which would predict if the person's salary is above 50K or below 50K. So in the data, I do see some hint as to, as you age, your salary would be higher than 50K. So that's just the raw data. Now I'm training the model using the explainable boosting machine, EBM. So I'm using that to fit my model using the training data. And then I am actually now asking my model to explain. So in the global explanations, what the model has learned on the global data set is what I am showing here. So it says that the model found that age is one of the key features, then marital status, then capital gains. These are some of the key features that contributed towards the prediction that the person's salary would be more than 50K or less than 50K. And then local explanation is where I get some idea as to how an individual prediction was made. So if you look at this, where the prediction was 1, that means it predicted that my salary is higher than 50K. And in actual reality, also the actual data also said that my salary was more than 50K. In that case, it also shows that capital gain is one of the features that contributed to that prediction that my salary would be more than 50K, which makes sense because if I have got a huge amount of capital gains, that would determine whether my salary is more than 50K. There are several other things, but I think I don't have any more time left. I will hand it over. If there are any questions, I'll see if I can answer some of those.